Welcome everyone on my talk on visual prediction of driver behavior in shared road areas. I'm Peter Gawronski and I'm with the Technical University of Munich. The short outline of our approach is the main idea that interactions are just resource competitions for a shared region. So first of all, we identify these static interaction regions you see here, which may have a yield sign or not, or it may be just because there's a narrow lane, and in all, when there's overlapping lanes, there's probably an interaction region there. Then we extract the motion goals for all vehicles. So for example, this vehicle could also go straight instead of turning left. And then we use the time to arrival, which is just the distance to that patch divided by the probable average velocity. And then we can calculate the delta TTA, and if it's less than 2 seconds, most likely there will be an interaction. Later on, we classify behavior based on the TTA prime, which is just the time derivative of the time to arrival. And by this, we'll be able to classify for the attention or the awareness of the other driver, and also if he collaborates with the first driver. First of all, about topology, we extract all data from the intersection drone dataset. It also provides lanelets. So these are just extracted lanelets. And in these, if we have overlapping lanes like here, we can check for trajectories which both go through these areas. So behavior analysis. The problem in a lot of approaches is that they use delta TTA. And the problem is that both of the vehicles influence it. So it's hard to determine which of the vehicles actually change this delta TTA, because here in this figure it is shown really clear. This is from the first vehicle and this is the collaboration, neutral or disruptive behavior from the other. But most often they just influence each other and you see that it moves in one way, but you do not know which vehicle it was. That's why it's more useful to use the TTA prime here at the bottom, because when the vehicle follows the expected velocity, it is just a straight line. And if we go faster, we just get a bump here, or we have a low part here. And also the collaboration or disruptive behavior is just interpreted by opposing behaviors, because that means that one vehicle accelerates and the other one slows down. Because if both vehicles accelerate for an interaction, they will crash in a few seconds. Just two short examples. There's one vehicle X coming from the top, and there's another vehicle Y coming from the right side. At the first moment when they see each other, the delta TTA is less than 1 second, so there definitely will be an interaction, if not even a collision. And the second vehicle Y has the right of way, so the first vehicle slows down significantly to let it pass. But as you see, the other vehicle does not stop accelerating, so actually it collaborates with the first vehicle because it passes this area earlier, so the second vehicle can accelerate here again. And at the very end, when the Y vehicle is at this intersection, the TTA is more than 2 seconds. The same scenario with two different vehicles. This time the first vehicle is a very aggressive driver, that's why it is accelerating heavily. You see these high numbers here. And at the point when we see the other vehicle, it is still accelerating, and the starting point is the same as here at the left side. But as you see now, this delta TTA drops to -2 because of aggressive acceleration of the X vehicle. But also the Y vehicle has a TTA prime of less than 1. That means that it actually brakes to let the other person in front. So this would be aggressive behavior from the X one, but also collaborative behavior of the Y vehicle. So in total, we see that vehicles act and react to each other in a natural way all of the time. And there's mainly these three categories. We get typical and unexpected behavior very quickly, just after short reaction time. We also see that this TTA prime is very meaningful in terms of behavior analysis, that we can classify behavior in terms of awareness and collaboration by just analyzing the first stimulus and the opponent's reaction. The only source here is the intersection drone dataset. Thank you very much for listening.